Hello, my name's John and I'm here today to give this brief webinar presentation of the use of MicroGDS in master planning. I'm a practicing architect. I use MicroGDS on a daily basis and have done for many years, so Informatics thought I might be an ideal candidate to give you some insight into what can be achieved with MicroGDS in master planning terms. In general terms, a master plan provides a vision for and a rationale to support the physical development of any area over an extended timescale. In an architectural or development context, it's used for any site where there are multiple buildings or other physical elements in order to manage and coordinate each of these elements in the context of the whole site. It will include not only the individual projects but also the infrastructure such as roads, services, amenities and so on. And in some cases it will be used to establish or modify transportation plans and such like. Site can be very small, incorporating an individual project such as a school or a college, or it can be vast, encompassing an entire region. It's likely that individual buildings within the master plan will proceed at different times, and it will often be the case that these are designed by different professionals and have different clients. MicroGDS is well suited to use in a master planning context because of its ability to handle vast amounts of data over huge areas at perfect accuracy and in a multi-user environment. And not only that, you've got all of the capabilities that you would very often need to find in several applications with master planning workflows using other CAD solutions. So you've got all of the sketching and modelling and layout and data linking capabilities and presentation capabilities in MicroGDS as well. We'll start our tour of the features that are of interest in master planning by looking at the way that MicroGDS processes Ordnance Survey master map data. It's capable of handling the master map data without having to purchase any additional software, which is not something that can be said for most other CAD applications out there. And the way that we do that is we use a tool that comes with MicroGDS, for which I've just set up a little menu here, and we simply identify the GML file that we've received from the Ordnance Survey that we're interested in processing, and we identify the location where we want to save the output. In this case I'm just going to type in the word map, and it will create an XML file in a MicroGDS format. Click on Save, and then we would click on Convert. I'm not going to do that now because it will take quite a few minutes to process the whole map. This particular map is a very large extent, and I've already set up the file for us to look at. So I'll just click on Cancel. The next step is simply to go to the File menu, File Open, select all MicroGDS file types. In this case we're looking for an XML file. We identify the XML file, and then we would click on Open. And again, I'm not going to do that because of the time it would take to import the XML data into a MicroGDS drawing. Instead, what I'll do is I'll open the drawing that's already been imported. I'm going to use this drawing as well to demonstrate a number of other features. The data itself is the Ordnance Survey sample data that anyone can download and test themselves from the Ordnance Survey website. It's actually a 5 kilometre square tile of the central city area of Exeter. As you can see here, what we've got is an initial view that I've set up here, which is zoomed in onto the cathedral, and it shows all of the master map data presented exactly as it is in Ordnance Survey. The information is all of the colours and all of the line styles and everything are all provided with MicroGDS, so that the presentation is exactly as you would expect. You can set up as many different views of the data as you wish. If we look at our Exeter drawing here, we've got the cathedral view open. We can switch to a view of the castle. View I've set up here of the Flower Pot Lane area, and another one here which is the whole of the main tile area. As you can see, MicroGDS is handling large amounts of data very efficiently. If you need even larger extents, you can bring the data into your file or into the project if you're working in a multi-user project, or you can choose to have the data kept in separate tiles and then just bring them together for the final presentation. To set up a view, you just zoom to the area that you're interested in. So for example, if you were interested in the railway station area here, we can just zoom to that extent, and it's as simple as doing view, save view as, and we'll just call it railway station. And that's it. We can close that down. We can retrieve that view at any time now just by double clicking on the name of the view in the document organizer panel, as it's called over here. If we zoom to the full extent, we can see that what we have here is the basic tile with some other graphics for the infrastructure and the river extending beyond that tile. If we return to our initial view, the cathedral view, we can do quite a lot of things with this data, and all of it is useful for master planning purposes. The first thing is perhaps you don't want to see all of the colour shaded areas, so it's quite simple just to set up an outline version of the same drawing. So you can manipulate that. It's not a different set of data, it's exactly the same data, so any manipulation of the data that you do, such as deleting or adding graphics, will be reflected in all of the different versions of the view. You can choose to set up another view which has just got the buildings highlighted in grey. Again, exactly the same data set, no additional work required. And you can also set up a view that incorporates raster imagery. This itself was downloaded from the Ordnance Survey sample dataset, but you can acquire the aerial views from any source that provides these, and there are quite a number in different parts of the world. And in this case we've got the outline data overlaid onto the raster map as well. So you can see, we can zoom to the extents and you see the cathedral area here, and then the raster tile. The raster tiles are a quarter the extent of the actual data set itself, so the 5 kilometre data set, it's a 2.5 kilometre square tile. The facilities in MicroGDS allow you to manipulate your data in any way that suits your own requirements. So for one of the examples we're going to use here is a thematic map. So if we look on this particular window here, we can open up our initial drawing. Again, it's exactly the same data set, but what we've done is we've attached attributes to each of the building objects in the drawing that describe, in this case, the use of the particular building. This could be stored as it is here within the drawing itself, or it can be extracted from an external database or a spreadsheet, or even a simple text file, a CSV file. So again, it's exactly the same data, it's just being presented in a different fashion. And this is very simple to set up. And if we look again at what we've got here now, if we look at our masking example, we have here a site area, and what we can do with this site area, so this is our area of interest, we can set up initially, for example, a site boundary. And I go to my view here, I've got the layer already set up, so I can just switch that on, so you can see the site boundary overlaid on there with one of the many styles that you can apply in MicroGDS, and it will allow you to create your own styles. There's pretty much no limit on what you can create. Ideally, what you'd want to do is work with a blank site area, but that doesn't have to involve creating a duplicate and deleting all of the contents of that area. We can simply work with something called a mask in MicroGDS terms and overlay the area with this mask infill, and that's just used the site boundary object that we created, and we just applied a different override to the style. In this case it's a mask. The data itself still exists, so if we go and look at our let's see, if we go and look at our original drawing, if we just turn off those two layers, we'll see that the data's still there to work on. If you plot the data, the underlying data isn't plotted, you just get the what is apparently a blank area of your site, and now you can start drawing within that site area.